interface gig 0 by 0, okay, or gig 0 by 0 directly. So the first thing we need to define name if. So what is the concept of name if, right? So whenever you need to give IP address on firewall, so always you need to give name. Name can be inside or it can be outside, it can be DMZ or it can be anything, right? It can be anything. So name if is required for what purpose? Name if is required because whenever we are giving uh, name is required for policies because firewall always match the name of interface instead of the interface number. Firewall match the name of interface, okay, instead of instead of number of the interface, right? So whenever you check uh, number of ASA, so that means whenever I'm going to configure, I need to give name to every interface. So when you check the route for the firewall or for any interface in routing table, you will not see any number. So if I have ASA and I'm connected here, so this is my like it's 0 by 1 interface. Here is my it's 0 by 0 interface. Here I'm giving 10.1.1.10.0/24 IP, and here is like 20.1.1.10/24 IP. So I need to give here names. So suppose I'm giving here inside name and I'm giving here outside name, right? So whenever you see both the routes in routing table as well, like this route is available in the routing table, so it will show you connected with which interface, inside interface. And similar with multi-network, it will show you connected with outside. So there will be no interface number. So similar with the policies. So when I'm going to configure any policy, so at that time I can see the interface name instead of the number. So that is the reason, okay? And there is one more thing that you need to know on firewall. So we have concept of security level, guys. We have concept of security level. So the range of the security level is range is 0 to 100, 0 to 100, okay? So in which level 0 is less trustworthy, okay? And level 100 is highest trustworthy. How it works, that we will discuss. Is the meaning of trustworthy, why I'm saying that, okay? But for now you need to remember the number 0 is the less trustworthy and level 100 is the higher trustworthy, okay? So whenever you give any name on the interface, okay, so when admin give name if to any interface on ASA, uh, instead of inside, okay, there is security level is 0. That means instead of inside interface, okay, inside name if you give inside name if, okay, instead of that every other interface have security level 0. Everyone have security level 0. So if I give inside name if to any interface, okay, to any interface, guys, so that interface have security level 100 security level. So that means if I configure my LAN interface on firewall which is connected with my domain inside, so that have automatically security level. But other than inside, if you configure anything outside DMZ, anything, so always they have security level 0. Always they have security level 0. I think these two things are clear. So now we can relate these things with ASA. If you got the idea, like security level is 0 to 100, 0 is less trustworthy, 100 is higher trustworthy, and if I configure any interface name with inside, so automatically that have security level is 100. If I configure outside, so it have security level 0, right? So now how these things are matters for ASA. Let's discuss about that. So if I talk about Cisco Firewall, so Cisco Firewall forwarding data, but how it's forwarding the data? So Cisco ASA, okay. So by default, traffic is allowed to send from higher security level to lower security level. Okay, so that means we can send data from higher to lower, but from lower security level to higher security level traffic is not allowed. Okay, let's try to understand these 2 points first. Okay, so mm, keep these 2 points in mind, guys. Okay, what I'm saying, if we are sending traffic from higher to lower, that traffic is allowed. But if firewall is sending traffic from lower to higher, that is not allowed. That is not allowed. Why? Try to understand this point. ASA. So here we have internet, right? And here we have LAN network like this. Okay. So these are the end users. So that means this is my inside interface. This is my outside interface. Right? So assume here we have security level 100, here we have security level 0. So that means which network is more trustworthy to us. So this is trusted network for us. Why? Because we know this is our LAN network and this is trusted network for me. Okay. And this is unsafe network for me. Why? Because this is open internet and there can be any type of security breach, right? So that's why what we are saying, if anyone trying to send data from higher to lower security level, that must be allowed. Why? Because higher to lower, so higher is your inside and lower is outside. So that means whenever traffic is moving from LAN to WAN, that must be allowed. So that is the ASA is saying in first point, right? So traffic is allowed to send from higher security level to lower security level. Okay. And at the same time, if any attacker, like here is anyone is located in the internet and trying to send data from WAN to LAN, so that must be denied. That must be denied. So that is the second point. So when traffic is initiating from lower security level and trying to move to higher security level, so that should not be allowed. That should not be allowed. So that is the function of ASA. So ASA is saying if anyone is sending data from LAN to WAN network, so that is moving from a trusted network to untrusted, I can send this data. Okay, so ASA is saying if traffic is coming from untrusted network to my trusted network, that should not be allowed. That should not be allowed. Are you getting my point, guys? Everyone, these 2 points are clear to everyone? Okay, so just you can put your questions here, guys, if you have any doubt, or you can say okay, just let me know. Okay, great. So now, if these 2 points are clear, let's discuss about more thing. So here I have Cisco ASA. So suppose we have multiple interfaces like this on firewall, and every interface have security level. So here we have security level 100 on this interface. Just let me put directly the security level number. Okay, 60, 40, and 20. Okay, so we have four interfaces. So that means, as we said, we discussed, the higher to lower traffic is allowed, right? But the traffic is not allowed from lower to higher. So this is allowed, but not this, right? So in this example, if the traffic is moving from higher to lower security level, it will allowed. If higher to lower here, it will allowed, and even it will allowed here, right? But at that point, if anyone is trying to send data, like the traffic is trying to move from lower security level 20 to 40 like this, so this should not be allowed, this should not be allowed, right? So that is the fundamental of the firewall. But how the firewall is making sure that if traffic is coming from lower to higher, this should be denied? Like, what is behind that? Like, how firewall is taking care of that? We want to understand the mechanism, right? Just with a single line, we can't understand the entire concept, how ASA is behaving, how ASA is checking the data, and what ASA is doing. That we just know, if lower to higher traffic is moving, firewall will deny that, right? But the point is here, how firewall is doing that, how firewall is doing that. Okay, so we need to understand. So every interface on firewall, every interface have security level policy. What I'm saying, let me repeat this point. Every interface have security level policy. Okay, so that means every interface have security level policy, except the interface which have lowest security level. That means every interface have security level policy, SLP. Okay, what I'm talking about this. Okay, so that means in this diagram, in this diagram, so this interface also have its SLP. This interface also have its SLP. This interface also have its SLP. But on this interface, there is no SLP. SLP is the security level policy which makes sure traffic must send to or not. How? Let me explain you. So suppose traffic is coming on this interface, right? And trying to move on security on 60 or 20 or 40 on any interface. So here the traffic is on the interface. So interface is going to check the SLP, security level policy. So security level policy is saying, okay, the traffic is moving from higher to lower, so you can send the traffic. Okay, so that is the task of SLP. So SLP is taking care about traffic must forward or not according to the security level number, right? So at the same time, if we have here interface number 40, and that is trying to send data to 60, so that is lower security level interface. So lower security level interface also have SLP, so that SLP drop the traffic on interface itself. Okay, so that is the task of SLP. So SLP is taking care, I have to send data on that interface or not according to the security level number. So if higher to lower, you can send that, right? If lower to higher, you must drop it. But in that case, we have one interface which has the lowest security level number 20, right? So this interface don't have any SLP in that case. Why? Because this is the lowest interface, so there is no security level policy. So whenever traffic is coming on that interface, guys, whenever traffic is coming on that interface, so according to SLP this can't drop the data. So then how and who is going to drop the data? Because we know the traffic moving from lower to higher is not allowed. So whenever traffic is coming on interface number 20, the interface number is not 20, actually that is security level number. Security level number 20 interface have no SLP, there is no SLP. So who is responsible to drop that data? Why? Because this is lower to higher. So lower to higher, we know traffic will drop. So at that time ASA have global policy. ASA have, guys, global policy, sorry, you can say global ACL. Global ACL. So there is global ACL that is like deny IP any, right? So that means if there is no SLP on the interface itself, so traffic will hand over to ASA, global ACL. So global ACL is going to drop that data, guys. In that case, who will drop that data? So this is the firewall, okay, and under the firewall we have deny IP any, right? So this is my global ACL. You can say global, okay. Now one interface is here, one and one, right? So here we have security level 100, 60, 40 and 20, right? So this interface have SLP, security level policy. This one also have, this one also have, but this interface don't have SLP, okay? So now if traffic is from higher to lower, so they will check the SLP and traffic is allowed. Why? Because from higher to lower there is no problem, higher to lower, okay. At the same time, if traffic is coming from lower and trying to move to the higher, so traffic will come on the interface and the firewall is going to check on this interface SLP. So SLP is saying lower to higher traffic is not allowed, so traffic will drop on this interface directly. In that case, this is this case number 2. What is the case number first? The case number first is saying if traffic is coming from higher to lower, so whenever traffic is coming on this interface, on higher interface, so firewall going to check interface SLP. So SLP is saying traffic is from higher to lower and that must be allowed, so that will allowed, that will pass, okay. In we have second case number. Second case number saying traffic is coming on a lower security level. So when traffic is coming lower security level interface, so interface is going to check the SLP. SLP is saying you are trying to send data from lower to higher, so that should be denied. So traffic will drop on this interface directly. So this is my case number 2. Now what is the case number 3? Case number 3 is saying there is no SLP interface. So whenever traffic is coming on that interface, so interface itself don't have SLP, so interface can't drop the traffic. So it will hand over the traffic global ACL, which is deny IP any. So here global ACL is going to drop the data. Who is going to drop the data, guys? Global ACL. Why? Because interface don't have SLP. Interface don't have SLP. And what is the reason? This is the lowest security level interface. That's why there is SLP. I hope my this point is clear to everyone. If this is clear, you will understand my next points. If there is any confusion, please let me know. I will repeat this point otherwise. Everyone? Daniel, Kenel, Sahir, Siva. These are the basics things, okay? Vidya, Vicky. Okay, Siva, great. Okay, now I'm talking about now traffic flow on ASA. So this is just the normal things we discussed about name, if, security level, SLP, and we know higher to lower traffic is allowed and lower to higher is not allowed, right? Why? Because interface is going to check the SLP and then traffic will drop. If interface don't have SLP, your global ACL will check and ACL will drop the traffic. Okay. So now I'm talking about here how firewall is going to check the traffic and what will be the initial traffic flow. I'm not talking here about the actual traffic flow. I'm talking about the initial traffic flow on ASA. So this is our point, guys. Okay. Initial means we will add few more things in future in this packet flow, but for now you have to make sure this is the packet flow. But I will change this packet flow with time whenever I'm going to add more topics like ACL, NAT, policies in firewall, right? So I will correct that flow with time. So currently you no need to manage that flow with Cisco flow, because I will give you Cisco packet flow after 3 to 4 classes. Okay, the exact Cisco traffic flow. Now we have here firewall ASA. So here is my server or something. This is my outside interface, and here is the inside. This have security level 100, security level 0. Okay. Now as I said, as I said, the traffic is allowed from higher to lower security level. Higher to lower security level, that is allowed, right? So now try to understand. So by default, Cisco ASA is to okay, it's forward three type of traffic actually by default: TCP, UDP, and layer 3 traffic, IP traffic. Okay, this these type of traffic. But currently I'm not using the exact word. I will introduce that word also. Just let me explain you one problem here in this packet flow. Okay, so what is the packet flow? First of all, you need to understand. So if this is user, this user have 10.1 IP. Here is 10.10 gateway, 20.10, and this is 20.2 for me, the server. Okay, so my user is trying to ping this server, or maybe the user is sending one TCP packet. Maybe I'm sending the telnet packet, right? What I'm sending? Sending the telnet data to my 20.2 user. Okay, so that traffic will forward through the ASA, through the ASA. So ASA have first of all this packet flow. ASA first of all going to check um, table SLP. Okay, accordingly firewall take the decision. So for now there are just two steps. When firewall is receiving any traffic on this interface, first of all it's going to check the routing table, and after routing table it will check the SLP where I have to forward or not. Okay, so suppose this traffic is coming to firewall. So here we have sources 10.1 and destination is 20.2. So this is some TCP packet, telnet packet, right? The SYN packet. So the first packet is coming to the firewall interface. So firewall is going to check on this interface first of all routing table. So in routing table they check the outside interface is this one. Why? Because the 20 network is belong to outside interface, right? So now after that firewall check the security level policy, and firewall get to know it's from higher to lower. So traffic must allowed. Traffic must allowed. So firewall will forward that traffic to your server. So server is receiving the TCP packet. Maybe this is SYN packet of your three-way handshake. Why? Because whenever you try to do any telnet or SSH connection, if that's belong to TCP, so TCP always have three-way handshake, right? So the first packet is maybe your synchronization packet generated by 10.1 to 20.2. So 20.2 is receiving the traffic traffic. Now this is going to back sync plus acknowledgement, right? Source is 20.2 and destination is 10.1. So this packet is now created by the server, and server sending this packet to firewall. So firewall is receiving packet on this interface. So firewall first going to check the routing table. In routing table, firewall get to know I need to send the traffic on this interface inside interface. But after that, firewall check the SLP. So the first thing, this is the interface which have lowest security level. So there is no SLP. So directly traffic will not drop on the interface. So interface hand over the traffic to the global ACL, and that global ACL is, guys, deny IP any, right? So that means firewall will drop this traffic on global ACL. So that means whenever user is sending data to WAN, that is allowed, but whenever WAN device is sending back your data, that is also denied. I'm not talking about like if there is any user who generates data by itself, but in that case initiator is this user and this server is responder, right? So responder traffic must pass through the ASA. So for that, what I need to do in that case, if traffic is dropping on this interface because of the security level or because of global ACL, so what I can do, that first thing is coming in my mind. I will create a policy. In that policy, I will say this TCP traffic must allowed whenever coming from outside interface to, guys, inside interface, right? So I can create a policy on this interface, but whenever we are using such type of policy on WAN interface, those are creating some security concerns for me. Those are creating some security concerns, okay? Because I'm allowing some TCP traffic from outside to inside, okay? So that means if initiator is sending some TCP packet, maybe that can also allowed for me, but I don't want. What I'm trying to achieve, if initiator is my LAN user which is sending data to WAN device for some services, so this is responder, this is not initiator. So responder traffic must allowed, responder traffic must allowed, right? So for that purpose, Cisco ASC have one function that is known as okay, default packet inspection, guys. So Cisco ASC have default inspection engine. What is the meaning of inspection engine, guys? Inspection engine means Cisco firewall is going to inspect my traffic, okay, and at the time of reverse traffic, it will allow my traffic automatically. Okay, let me explain you. Like in above diagram, what we did, the traffic is forwarded to server, but server traffic is dropped on ASA. So ASA have now inspection engine. ASA have now inspection engine. ASA have inspection engine. So that inspection engine create entry. So whenever traffic is forwarding from higher to lower, so at that time ASA going to inspect your traffic, and that inspected traffic is going to be create entry in your one table, and that table is known as, guys, connection table. That table is known as connection table, right? So connection table is going to check for reverse traffic when this server is giving you reply. So at that time they check the connection table and pass the traffic without any policy. Okay, let me repeat. So now we have here firewall. So this user have 10.1 IP, 10.10 inside, outside, 20.10, 20.2, right? So by default, Cisco ASA inspect two type of traffic: TCP and UDP traffic, guys. Okay. So by default, Cisco firewall inspect TCP and UDP traffic. So right now we are sending here one TCP synchronization packet from 10.1 to 20.2, right? So at that time, whenever firewall inspect the traffic, firewall need two, three things actually. Whenever they are inspecting the traffic, they need three things, okay, in that data. So during the inspection, they need source IP, destination IP, okay, source port number, TCP UDP port number, okay, destination port number, and protocol. So these five things required. Okay, five means source and destination, port number, IP, and protocol number. Protocol means TCP or UDP. Okay, protocol is TCP or UDP. Now the user is sending data. User is sending data, so they have maybe source port number, a random port number, destination port number is 23 because of telnet traffic. Okay, so the traffic is coming to the firewall on inside interface. So the first thing now, okay, now try to understand. Now there is small change in packet flow. So the first they are always going to check the connection table. Connection table means which have entry for traffic inspection. Okay, if there is no entry in connection table, now firewall is going to check the routing table. Which table, guys? Routing table. If there is entry, then they are going to check the SLP. Okay, now this interface is receiving the traffic for the first time. So if the traffic is coming for the first time, there should be no entry in the connection table. Okay, so there is no entry in the connection table. So now device is going to check the routing table. So in routing table, they check the destination is 20.2, which belongs to the outside interface. Okay, after that, firewall know this is my exit interface. So from routing table, router get to know about exit interface, which is the exit interface. And once firewall know the exit interface, now firewall is going to check the SLP. So SLP says, okay, traffic is allowed from higher to lower, there is no problem. So when traffic is coming on the exit interface, okay, so at that time firewall create entry into your connection table, that is con table. You can say con table or connection table. So connection table have one entry, 10.1 user using the random port number and trying to send data to 20.1.1.2 on port number 23, and the traffic belongs to TCP. So this is entry created into connection table. Okay, so now traffic passed to the server, right? So now server is giving you response. And what is the response, guys? So response have now source IP. Okay, this is your SYN plus acknowledgement packet, maybe this time. Source is 20.2, destination is 10.1, port number is source 23, destination is 1024. Okay, random port number. So this is your reply packet, or you can say simplest acknowledgement packet. So the traffic is coming on this interface. So what is the first thing firewall is going to check now? The first thing firewall is going to check the connection table. Now this is the connection table. So in connection table, they are going to check entry for this traffic. So they got here entry. Okay, so this 20.ip going to match with the port number, and 10 IP with the port number and the protocol, right? So entries exist. So without checking anything, just checking the connection table, without checking routing table, without taking care of SLP, so they can directly send the traffic to inside interface and traffic will pass. So that means Cisco firewall is inspecting the TCP and UDP traffic. So that means if any traffic is coming from LAN to WAN, that entry created into connection table. And this entry is checked during the reverse traffic. So that's why I no need to create any specific policy on my WAN port for return traffic. So this is the inspection engine behavior of Cisco Firewall. So Cisco Firewall have inspection engine to inspect the TCP and UDP traffic by default. But by default, it never inspect the IP traffic. Why? Because IP traffic never have source and destination port number. This is the reason. But we can make this traffic also inspect. We will see how we can do that. But till here, if this point is clear to everyone, what is the meaning of inspection on Cisco Firewall? Let me know. Inspection means firewall is checking the traffic which is passing through it, okay, during the higher to lower. So for that, firewall create entry into connection table, and traffic when reverse traffic is coming for the same entry, that is automatically allowed from lower to higher without checking SLP and anything. Without checking SLP and anything. So if this point is clear to everyone, I can show you in practical these things. Guys, Miguel, okay, Vidya, Siva, Sehir, okay, Kenel,
Yes, yes, yes.
okay, great. Okay, guys. So first of all, I will show you the traffic inspection for TCP and UDP traffic, and later on we will do inspection for IP traffic. Okay. So let me start with the practical. Okay. So let me start my all the nodes. So right now I'm using here one image, and what is that version? I can show you. The firewall is already running. Okay, and I hope this diagram is visible to everyone. So this is ASAV. ASA is virtual ASA, and 9.6 version is this time. Okay, 9.61. So this version I'm using here. So 0 by 0 interface is connected with my switch, that is the LAN switch. 0 by 1 with the WAN, and this is the DMZ. DMZ actually, this is demilitarized zone. So demilitarized zone is actually where we can install the servers and all. Okay, but we are not using today about this zone and all. So we will just make sure about the traffic pass through ASA from inside to outside. And I think now router router 2. So I'm starting with the configuration on the routers, so you are already aware, or maybe the configuration is already there. So let me wipe out for you, so you will see what configuration we are going to do. So whatever configuration I'm going to do today, I will save this configuration, okay, for next lecture also. So until the devices are going to boot, so we have already here Cisco Firewall, and if the configuration is here, if you check the interface, show interface IP brief command, okay. So till now we don't have any configuration anything. Now I'm going to configure gig 0 by 0 interface first. So we need to move here, interface gig 0 by 0, no shutdown the interface, name if the interface, if I'm giving here inside directly, right? So inside automatically give the security level 100 to itself, okay, because as it mentioned. And now we can give IP address 10.1.1.10/24, okay. And the next interface is gig 0 by 1. Name if is outside. So you can give any other interface name you give, except then except expect inside there is always security level 0. You can give manually if you want to give with this command, okay? But here we don't need to require IP address, okay? So we have configured here, and if you check, let me give the host name ASA and show interface IP, and you can check we have now IP address, and even both routes are visible into the routing table. So the command is show route, okay? So you can check show route command have interface name instead of the number of the interface gig 0 by 0, 0 by 1. No, the number is not required, name is required actually, okay? So this is the main reason. That's why I told you the name if is very important, okay? Now we have configured both interfaces, so we have not doing anything else. So now time to configure the R1, so I can pass the traffic and show you that, okay? I can pass the traffic and show you. So the host name is R1, interface is 0 by 0, no shutdown, IP address 10.1, okay? And we need to give here one default route so it can reach to the 20 network. Okay, I configured it, and let me try to ping the ASA. So yeah, ASA is reachable, similar on R2. Host name is R2, interface is 0 by 0, no shutdown, IP address 20.2/24, and we can give here also default route so it can reach to 10 network. And next up is firewall outside interface, okay? And I need to enable here some services also, so I can give here username. Username is not required. Okay, I can give privilege. Okay, IP HTTP server, IP HTTP authentication local, okay? And I need to enable login local, transport input all, okay? Yeah, that's enough. And now I'm on R1, right? So on ASA, the first thing, ASA have some global policies. So those global policies we can use to inspect the traffic. So by default, TCP UDP traffic is TCP and UDP traffic is inspected by default, okay? But make sure not because of not because of global policies. If you remove the global policies, still your traffic will inspect. So that is by default inspected, okay? So in global policies we can inspect maybe IP traffic, or we can inspect some other traffic. We will see how we can do that, okay? But try to understand, TCP UDP traffic is inspected by default. That is not because of global policies, okay? So if you remove the global policies or you change the global policies, it will not affect anything. And how to check the global policies? Show run policy map. So here you have policy map, you can see. So this is your global policy. Okay, under that you have here one class map which is with inspection default. Okay, so you are inspecting here FTP traffic. Okay, and RSH, RT, TFTP and SIP traffic, right? But there is nothing like telnet, SSH or TCP traffic. Why? Because that is not part of it. And you have here one global service policy for that, that is applied. And you can check service policy, global policy, global. So that is by default here, right? The global policy. But this global policy is not inspecting your TCP and UDP traffic. Okay. But whenever I'm going to pass the traffic, so it will automatically inspect and it will show your entry into the connection table in con table. Okay. So for that, what I'm doing, I'm going to do the telnet 20.1.2. Okay. So you can see the traffic is passing. We have admin and Cisco, right? So now you can check if I have connection. If I have continue connection, I have here one entry, guys. So try to understand. We have one entry here. So the traffic is TCP sent to outside interface to IP 20.2 on 23 number port. Traffic is coming on inside interface with IP 10.1 with this random port number, right? This is the timer and the bytes, and we have here flags. So we have three flags. Up means like the session is up. I means inbound. Okay. So that means inbound traffic which come from outside to inside. Okay. And outbound traffic which go from inside to outside network, that is outside. If you do show con long, okay, with this command you will see here the logs and all these things in detail. The same thing here you have. Okay, outside with this, inside have this, but you can see your flags. And where is the flag? Wait, come on. We have UIO, right? So O means outbound. Outbound is always which traffic, guys. Make sure outbound means which initiated from higher to lower. Which initiated always higher to lower. That is outbound traffic. Okay, that is going to outside network. Okay, and if there is I is inbound. Where is capital I? Inbound data, right? So inbound means when traffic is coming from higher lower to higher security level, that is inbound. That is inbound, right? Okay. And U is up. Up means the connection is up. Okay. So that how you can check. So this connection, this con table create or remain your entry whenever traffic is passing. But once your session is done, like if I'm going to delete here the session, what I'm going to do, I'm going to exit. So at the same moment, it will remove the entry or not. Let's see. Yeah, there is no entry. If you check con table, there is no entry. So con table create or remain the active entries. If once your session is done, so the entry is no long. Okay, entry is no longer in the table. Are you getting my point, everyone? Guys, okay. So this is about telnet.
Yes, yes,
Okay,
yes.
and now what I'm going to do, I'm going to configure something for UDP traffic. So for UDP traffic, what I have to do, let me tell you. I'm going to configure this as my DNS server. Okay, I will create here some fake entries or like no entries here. So if I create here entry, it will send DNS query. Okay, it will inspect the traffic and here will be DNS reply at the in milliseconds. So at the same time, entry will delete for UDP. So what I have to do, I want to just remain the entry here. So I don't want any DNS reply. Are you getting my point? this R1 will send DNS query to DNS server. So who is DNS server? R2. Okay. But I don't want R to give the reply. Why? Because if R to give the reply, my entry will be deleted as soon as possible. So I can't even see the entry for UDP traffic. But I want to show you how this firewall is inspecting UDP traffic. So just it will send and it will resolve it. Okay. So for the first time, I will just show you, and then I will create here entry. Like I want to create here cisco.com or something like this. So on R2, R2 is my DNS server, right? IP DNS server. This is the command. IP domain lookup. Okay. And on R1, I will say who is your DNS server. IP name server 20.2. So just I created. Okay. And now I'm going to telnet it. Telnet the cisco.com. So cisco.com R1 don't know who is cisco.com. So R1 knows is the DNS. So I will send DNS request to R2, right? So this is sending request to domain server. So at that time you can see the entry. See, we have UDP entry here, port number 53, right? Entries here. Okay, but the flags are not visible. Why? Still the traffic is not coming. So until unless I'm going to configure IP host cisco.com 2. Wait a minute, I did wrong. Okay, now maybe I will get the reply. Bad address. Let me try again. So this time, yeah, it resolves my IP address. Okay. So now my entry will not be remain. Why? Because it created a telnet connection now. Yeah, we can see. Right. Maybe the last entry. I'm not sure because it happened around 40 seconds ago. That is the last entry. Uh, at that time, the DNS query was not resolved, right? That's why this entry is still here. So it will take some timeout because of the traffic. The entry is still here. Okay, but for the second time there is no entry of UDP. Why? Because that entry is deleted as soon as your reply is coming to ASA, right? So that's why you have now here access. So that how you can check ASA is still inspecting the TCP and UDP traffic. But now what I'm trying to do, let me open it. I can show you one thing. Ping 1.2. So I tried to ping. So ASC will create the entry, but it will not inspect the reverse traffic. You can see the ICMP traffic have entry in connection table. So ASC will create entry in con table. That is not issue. So when ICMP traffic is passing through, it will create the entry in con table. But when traffic is coming back, so they will never check the con table. Why? Because IP traffic is not inspected by default. That is separate thing. They create the entry in connection table, but I'm talking about the inspection. So how you can check that? Let's do one thing. Logging enable, logging console 7. Okay, now let me try to ping again. So you can check deny inbound ICMP whenever source is 20.2 and destination is inside 10.1. So traffic is denied at that time. Why? Because there is no policy or that traffic is not inspected by default. So by default, IP traffic is not inspected, guys. So we have to inspect it, or we need to configure policy for that. Okay. So till now we just discussed about the TCP and UDP, but if I have such type of traffic, I need to inspect it. So what I can do, so for the first time, I want to use my global policy and global ACL. Show run policy map. Okay. So here we have global policy. If you check, So I am moving into the global policy and global ASEAN. Okay, copy paste it, enter it. Here you have to use inspect ICMP and leave it. Okay, leave it. So now if you check show run policy, see inspect ICMP. So what is the command? If you check, this is the command. I move inside the global policy. Under that, I move inside the class which is inspection default, and I put this command inspect ICMP. I think this is clear. And this global policy is already applied on the device. This global policy is already applied in the global service policy. Okay, so you can check this is applied here. So now if you send the traffic, you can see we have reply, and there must be entry, but I need to send traffic again. Come on. Yeah, you can see. So entry is here now, right? So I simply traffic is inspected. So I hope this is clear to everyone how traffic is inspected on firewall this time. Guys,
Can you just go back small on the ICMP traffic?
okay.
Yeah, just that side.
So
I'm okay.
what do you mean the slow? The
No,
traffic is
the
uh-huh.
inspection of the ICMP traffic, the policy you created.
The policy. Okay, let me show you
Yes.
the policy. So I used the global policy which exists on the firewall. Okay. So firewall have default policy. The policy name is global policy. Okay. So policy map, global policy. Under that you have class map, which have inspection underscore default name. Under that I use inspect ICMP command. Okay. So after that, if you
Okay.
check under the global policy, show policy map. Wait a minute. Show run policy. I think this command you need to check. Show run policy map, and here you can see global
Okay.
policy. Okay, and under that we just put this command, and now traffic is inspecting. So this is the
Okay.
first thing. You can use the global policy, but maybe you don't want to use the global policy, or you want to do some separate policies, like you want some changes, you want to allow and disallow some traffic, or maybe you want to limit the traffic. At that time we can use our own policies. I will show you how we can do that. Okay, but I hope this is
Okay.
clear till now. Okay,
Yeah, this is fine. Yeah.
yeah. So now what is the next? I can remove this here, this one from here, and let me remove it. Okay, so I removed it, but still the global policy is applied on the device, right? So what I'm trying to show you this time, show run service policy. So I'm going to remove this policy now, just to show you if we remove the global policy from the firewall, so will there any effect on TCP and UDP traffic inspection? No. So if you check now, the policy is not applied on the box, right? Policy is just existing on the device, but this is not applied. Why? Because I removed with this command, right? Okay, but now if I try to send some TCP and UDP data, still still device is able to log in, right? If you check, there is no policy, but still we have enter in connection table. So that means TCP and UDP traffic is not dependent on the global policy. TCP and UDP traffic is not dependent on the global policy. But right now, even my ICMP is not working. Why? Because I removed the ICMP, the first thing, and the second, I removed the policy also, right? So even my ICMP is not working. So instead of apply inside the global policy, I can use this command, fix up protocol ICMP. So this protocol automatically, this command automatically allow the ICMP inside the global policy. If you check, now global policies automatically apply on the device also. See, now this is applied. Why? Because I put this command. Because of this command, the global policy is automatically applied on the firewall now. And if you remember, last time we removed the ICMP from the policy. Let me, yeah, see, uh, yeah, here ICMP was there, right? So what I did, I removed this command, if you remember, right? And after that, I removed the global policy also, just to show you TCP and UDP inspection. But now I did one command here. So because of that command, ICMP again allowed in the global policy, and global policy also automatically applied in the device. So now if you send ICMP traffic, it will allow. See, and if you check, show run policy map, it's here again. So I don't need to go inside the policy. I can just put fix up protocol ICMP. I did this command. Okay, so after this command, automatically server service policy is applied on the firewall in global mode, and now ICMP traffic is also applied. So now device is inspecting the TCP, UDP, IP traffic, guys. Which traffic? IP traffic. So what we can do after that, like we can control the traffic what is inspecting by the firewall. What I mean, like we can control the TCP traffic, or we can control the UDP traffic. Like I can control the number of TCP session, like how many TCP session they can create. So just suppose we have multiple users, right? So this user is trying to take telnet of this router, and maybe there is also one more user that is also trying to take telnet of this router. So I can control only one device can take telnet at a time, right? So we can do that. So what I'm doing now, I can create the separate policies. Okay, so first of all, I need to create ACL to match the traffic, guys. Okay, make sure what we need to do. We want to inspect the TCP traffic, so we need to create here ACL with access list command. I can give the name is like telnet. I want to inspect the telnet traffic. You have to permit the traffic, and source can be anyone, like 10.1. Okay, wait a minute, or I can do. I need to match the protocol. Source any, destination any, and port number 23. So that is my telnet traffic, right? And now this thing you have to match inside the class map, which is CMap. Match access list, and access list is, guys, telnet. Okay, and now you need to move inside the policy map. Policy map is pmap for me. You can give any name. Okay, so I can remember these names, that's why I'm giving. You have to call the class map it, and here you have to give the inspect. And what do you want to inspect? I want to inspect the TCP traffic. Wait a minute, traffic is already inspected. So what we have to do, we have to do set connection. Okay, and I can control the max connection here with this command, right? Con max. So here is one connection for me. That means I just want to apply one connection or one remote connection at a time. Okay, not multiple. And now we have to apply this configuration under the service policy. Okay, the policy name is pmap. What is your policy name? Okay, and you want to apply on interface inside because we want to configure this on inside interface. So that means what we did, we have matched that TCP traffic 23, and that we call inside the class map. Class map later on we call inside the
Policy map.
policy map. Yeah, policy map have class map, and here we did set connection and max
Connection.
connection is one. That means if anyone trying to, okay, and later on we apply the service policy on my which interface, guys? Inside
Inside.
inside. That means, so whenever traffic is coming on inside interface, so this interface is going to check the TCP traffic which have port number 23, right? And only allowed one TCP connection at a time for telnet traffic. For which traffic? Telnet traffic. That we did here. Okay, but right now I don't have multiple routers. What I can do, okay, is applied. I can show you here. Show service policy interface inside, and you can see we have service policy pmap which have class map, and we connect the max connection one. Okay, so now I need to use one more router here. Okay, let me down the switch. So we can make it 10.2. Okay, okay, let me configure this router also. Okay, IP route. Okay, now we configured both the routers. So I have just inspected one connection at a time. So if I'm going to take telnet from this one, R1, it can take telnet, admin, and Cisco. But at the similar time, if I'm trying to access from R5, R5 is also part of same LAN. Traffic is coming to the this interface, and this interface have policy this time, right? See, just trying. So what you have to do? Let me do one thing. Okay, I enabled the logs. Now see, connection limit exceed for input packet from 10.5, which is R5, right? On this port, with this port number for 20.2. On which interface, guys? Inside interface. That is not visible here, but the interface is inside. If I try again from R5, I can see again clear log message. See, the traffic is on interface inside. Okay, so that how we can see the traffic inspected through the firewall. So we can limit the things, right? Okay. So you can see what policy we did here. So first of all, we create the access list. Access list is this one, which permit the TCP traffic and telnet port number, right? So you can see the 9 packets are matched with this ACL. Okay. And show run class map. We created here one class map which match the ACL telnet, this ACL, right? And after that we have show run policy map, and this is the default one. Here is our, this is the policy, right? And then we applied in the service policy. So that service policy we applied. I think this is clear to everyone, right? Guys,
Yeah, it's very clear.
okay. So this is how you can inspect your telnet traffic. Okay. So if you want to inspect your ICMP traffic, so currently ICMP is part of this, so it will allow all of traffic, right? So what I want to do, I have already like this policy map, so I don't need to create multiple policy map, because one policy map PMAP is already allowed here, already applied on this interface. So just I can create other class map for ICMP traffic, and I can match and I can create ACL. So that class map I can make part of same PMAP ACL, sorry, PMAP policy. Okay. So we can inspect multiple traffic with a single policy, you can say. So what I want to do, I will remove the ICMP traffic from, and I want to inspect this traffic now. So I will remove first it. Okay. Now inspect ICMP. I removed it. And now I need to create ACL first because I want to match the traffic. Access list. The name is ICMP and permit. And I want to inspect only from one this time. So this is my ICMP traffic from a host 10.5 to host 22, right? And now create the class map. Class map name is also, it should be different, so I'm using ICMP. Okay. And wait a minute, match access list name is ICMP. Okay. So this access this class map we have to match in the previous policy map. And what is the previous policy map, guys? Shoran, policy map. See, this time ICMP is not, so I'm using this one, this PMAP. Okay. And now under that class map is ICMP this time, because we are using ICMP class map, and we want to inspect. Wait a minute. Ah, no need to say inspect because already traffic is matched, right? Yeah, we matched the traffic.
You are passing the ICMP traffic already, so
Yeah, I need to say inspect, right? That is required. Inspect ICMP because ACL have ICMP traffic, and that ICMP traffic we have to inspect here. So you have to call it here also. So these are the commands. Okay. If you check what we did here, so don't be confused. So just we created ACL which match only this traffic. Okay. Source is 10.5, destination is 20.2 ICMP traffic, and we create a class map name ICMP and match this ACL. Though above ACL is part of this class map, and later on this class map is part of the previous policy map, and under that we say inspect ICMP. That means if any traffic is coming in this class map, so you have to inspect ICMP traffic in that. And even we are only receiving the ICMP traffic, right? Because we match the specific ICMP traffic in ACL. This time,
Oh, oh,
yeah, yes, please.
wait. Let me just see what.
Because what traffic I matched inside ACL, I have to inspect that traffic here.
Yeah.
So
Okay.
that what I configured, right? So that
Yeah.
means match this traffic and
Mhm.
inspect this traffic in my policy. And
Okay.
that policy is applied already because this policy, this PMAP have two policies now. One for telnet, if you remember, one for ICMP. If I will show you global show run policy map. See, we have here global policy
Yeah.
PMAP. It have class map that is matching the telnet connection one, right? And
Hmm.
second class is ICMP, which is inspecting ICMP traffic,
Yeah.
because you can configure only one service policy on interface. So I have configured service policy PMAP, right? So PMAP have
Yeah.
now two class map. So there can be multiple classes inside it, like ICMP and telnet and SSH and UDP, anything. So there can be n number of class map inside this PMAP, which I want to
Okay.
inspect on my inside interface. Okay. So PMAP is always one. Okay, but under PMAP there can be multiple class maps, multiple ACLs in these class maps. Okay.
Yeah.
And now we can see, if we try to ping from here, exit, there is no ping. Why? Because traffic is not coming from 10.1, right? If traffic is traffic is coming from 10.1, not from 10.5. My bad. This is the 10.5. It have to ping to 20. Not 5. So that when 10.5 is sending data to 20.2, that is masked, right? And you can see ICMP connection from this to this is allowed, right? Okay. So is there any doubt, guys? And you can see the ICMP connection is denied from 10.1 to 20.2. Why? Because that is not in your inspection. That is not in your inspection. Okay. So just I'm explaining here. Firewall inspect by default TCP and UDP traffic. But even TCP and UDP traffic you can control, right? And for ICMP traffic you can create the separate policies so they can match the traffic and forward it. So I guess this is clear to everyone how firewall is inspecting the traffic here. Okay. So if this is clear, I'm moving with the next topic, guys. Guys, I hope this is clear to everyone. If you have any doubt, let me know. Okay. Okay. So let's continue with the next topic on firewall. Just a minute. Okay. So the next topic is, so everyone is aware about that, right? Access control list. So guys, everyone knows about we have two type of ACL, normally standard and extended. So if we talk about ASA support standard and extended ACL. Okay, but by default there is nothing which can say this is standard or extended ACL. Okay, so that means there is no differentiation between standard and extended ACL with name and number on firewall. So you can say on ASA, name and number of ACL cannot define about standard and extended ACL. That means if I'm giving name or number, you can't say this is standard or extended. Why? Because according to the configuration of ACL, it defines this is standard or extended. So if you remember right now, I configured one ACL on firewall to inspect ICMP and TCP traffic. That is extended ACL. So mostly we will see mostly extended ACLs are visible for policy configuration. Okay, on a, so we can see extended ACL mostly, and standard ACLs only visible at the time of VPNs. Okay, only use VPN section. So in VPN section we will see what is standard ACL. Now if I configure any ACL, what will be the effect of it? What will be the effect of it? Okay guys, let me tell you. Okay, so this is user 10.1, 10.10, 20.10, 20.2, right? So what I'm going to do, so there is one point you need to remember, and what is that point? If ACL is configured on interface, that will override the SLP of interface. That means if you configure ACL on interface, okay, so it will not check now SLP, it will check the ACL and forward accordingly. It will check the ACL and forward accordingly. Okay, so that means if I apply here one ACL on this interface, what I'm going to apply, suppose I want to permit CMP from my host 10.1 to which host 20.2, right? So this is my ACL, and I applied the ACL access group. ACL name is like ICMP, okay, for an example, and interface you have to say in interface inside. Okay, in interface, that is direction in or out. Okay, interface inside, so like this is the command. So in that case traffic is coming to the firewall. So as I remember, or as I told you, not as remember, firewall always going to check first of all connection table, right? Firewall going to check connection table, but for the first time there will be no entry in connection table, and I told you router is it's going to check the routing table. So routing table always show you the exit interface, which is this one. Okay, so here security level 100, here is 0. Now You have here ACL, so this time it will not check the SLP. This is going to check the ACL because ACL override the SLP. So in ACL it's going to check we have to permit from 10.1 to 20.2 on this interface, and after that firewall going to create entry into con table, guys, into con table. So the point is here, if you apply ACL on interface, it will just override your SLP doesn't matter now. So whatever in the ACL, whatever you have permitted, only that traffic is allowed, only that traffic is allowed. Are you getting my point? Everyone. Okay, now this is about which traffic is going to be match. Okay, this traffic is about which is going to be match in the ACL. So 10.1 is going to be match, so that will be permitted. So I have only permitted 10.1 in this ACL. I have not permitted other IP 10.5. So what if 10.5 try to send the data? Okay, before that you need to understand how ACL works on ASA. So we can apply on ASA. This is ASA, this interface and this interface, right? So we have here inside interface and this is my outside interface, or you can say direction. So if I have ACL on my in interface and I don't have global ACL, I don't have ACL on outside interface. Okay. So this ACL have implicit deny. This ACL have implicit deny. That means whatever traffic is permitting in the ACL, that is okay. But if that is not matched with the permit statement, so the on the same interface, same ACL have implicit deny. Same ACL have, guys, implicit deny. Are you getting my point? What I'm trying to explain you, if I apply one ACL on this interface in direction, okay, and there is no any other ACL on ASA, there is no ACL on this interface, there is no global ACL. I will explain you about global ACL. By mistake I previously say here global ACL, that is actually global policy, guys, which have deny statement. Okay, not global ACL. Global ACL is something else. Okay. Now traffic is coming on in interface, that is going to match with the ACL. If traffic is coming from 10.1 going for 20.2, that will allowed. Okay, that will allowed and forward created entry. But what if traffic is coming from 10.5? Just a minute. हेलो, नहीं है उनके पास ही. हाँ ले लो फिर. नहीं अभी तो चल रही क्लास. हाँ ठीक है. Okay, so if traffic is coming with 10.5 to destination 20.2, so that traffic is not permitted, so that automatically part of implicit deny. Which implicit deny, guys? In which ACL? What I mean, the ACL which is applied on the interface, so same ACL have implicit deny in that case. So this is case number one. This is my case number one. When we have ACL, just one ACL in direction, and we don't have any other ACL like global ACL or outside interface ACL, so that inside ACL have implicit deny in that case. That is the case number one. Okay, but what if I'm using here global ACL also? What I'm using here, global ACL also. हाँ हाँ, एक को सब्जी थी, कड़ी. हाँ, और शायद कार्ड भी है। ठीक है। Okay. So in second case, so this is case number two. Okay. Now we have here ACL. Okay. And we have global ACL also, and we have ACL here also, like this. So if traffic is permitted here, that is not going to check anywhere. Why? Because traffic is matched in the ACL, and ACL will forward the traffic directly. Okay. If traffic is not matched here, okay, and even not matched with the global ACL, so that is going to be matched with your this policy. And if even here traffic is permitted, that is okay, no problem. Okay. But if traffic is not matched here and even not matched with the permit statement, then it's going to match here with the deny statement. Okay. So that means if my traffic is coming with 10.5 to moving to 20.2, so that is not going to match with this statement. Okay. Not even with the global ACL. So it will match with the ACL which is on outside interface. With which statement, guys? Deny statement. With which statement, guys? Deny statement. Okay. This is the second number case. And in third number, if we don't have outside interface ACL, so then deny entry is available on global ACL. Deny entry is available on, so ASA. Okay, so what is the third case? So in third case, we have here ACL and the permit statement. Okay, we have global ACL and there is no ACL on outside interface. Okay, so if traffic is coming with ACL and going to match with permit, so it will not match here. Traffic will allowed. Okay, why? Because if traffic is here, no need to match with the global ACL in that case. Okay, but in second case, if traffic is not going to match with the permit one here, so that is going to be match here with your deny statement. If there is no permit statement, it will match with the deny statement here, guys. Okay, so this is the third case. If you have any doubt regarding this case, let me know. So I just explained about the behavior of the ACL on firewall, but yet we have not configured the ACL. So we will start the ACL configuration tomorrow and we will discuss in detail about the ACL configuration. Okay, and what is the global ACL where we can configure?
Yeah, I'm already tired.
Okay.
All right. Thanks.
Because this topic will take time, so we don't have much
Yeah,
time, I
that's
guess.
okay. Yeah.
So tomorrow we will do ACL configuration and object configuration. Okay. If time allow,
Okay.
I will start with the net. Okay.
All right. Sure. Thank you.
Okay, guys. Thank you. Thank you so much. Have a good day. Bye.